Here we have something a little more complicated, and you might be thinking to yourself, "Whoa, like this has more letters than numbers." But that's fine. That's fine. Let's just have a look at it. So we see that x minus 2y over x equal to z, and we want to find x. So this shouldn't be too difficult, So how can we even begin to approach this? So like in the last example, I see that there's a fraction. Again, generally not easy to work with. So let's just try to get rid of this fraction. How can we get rid of this fraction? Just like in the last example, if you want to get rid of the fraction, just multiply both sides of the equation by whatever's on the denominator. So let's just multiply both equations here, or I'm sorry, both sides by x. And again, we are looking for x in terms of all the other variables. So in this case, x here cancels out, so you're just left with x minus 2y is equal to z x. Okay, so now at least it's all, again, in one line. Might be at least a little bit easier to look at. So we still have a problem, though. We still have a problem of having the same variable, x, what we're looking for, it's still on both sides of the equal sign. So we want to fix that. We at least want to have it on one side. So let's just scoot this x over here. How can we scoot it over there? Let's just subtract x from both sides of the equation. So you have then left on this side, right? This x goes away, so you just have negative 2y is equal to z x minus x. And that's where we're at, right? So now that you're here, you at least have all your x's on one side of the equation, exactly what you want, but it's a little bit weird because you have x in two separate terms. Now, this is actually kind of a common scenario. I'm sure you'll see it on your test. When you see something like this, you might even have it in three terms. I don't know. But when you see something like this, there's actually a very simple solution, even though it might seem like, how do you keep moving this stuff around to get x by itself? All you have to do, remember, when you see this, is you factor out the x. It might be another letter. It might, whatever it is, whatever you're looking for, just factor it out. So watch what will happen. What you'll get is negative 2y, still, right, is equal to z in parentheses minus 1 times x. Do you see what I did there? That's kind of, well, it's half the trick here, right? So I factored out the x, so I divided everything here by x, put it on the outside. You can check again. If you multiplied this back in, you would still get zx minus x, right? So we factored that out, and now it's a lot easier, right? Because now, watch, all you have to do is divide both sides by, whatever you're trying to get rid of. Not get rid of, but so here's x. We want to divide both sides by whatever isn't x. So why don't we just divide both sides here by z minus 1. Divide by z minus 1. So here it cancels out, and you have just your x left. So that's how you isolate it. So in the end, you get that negative 2y over z minus 1 is equal to x. All right. So I hope that makes sense. Again, the point here was that just like last time, if we see a fraction, we usually want to remove that fraction, turn it all into linear, and once it's there, you try to get the variable of interest, in this case x, variable of interest all on one side of your equal sign. And once you've done that, if you have it in more than one term, if you had it in just one term, then it wouldn't really be an issue. But since you had x here and x here, you just factor it out. Because once you factor it out, you can divide by whatever x isn't, and you get it by yourself. Or I'm sorry, by itself. So hope that makes sense. And let's go ahead and move on to a different example.